All right, I thought I'd go ahead and do a part 4 to my homebrew CNC, where I kind of go over a couple things. One of the things is going to be the limit switches that I decided to go with, and the other thing is the X and Y table. Now, let's just get the X and Y table off of the docket. My table is a 6-inch. Here we go. 6-inch by, let's see here, I believe an 18-inch. 18.5-inch table I got off of Amazon. It's made by Grizzly. They do a lot of industrial tools. It comes with adjustable gibs on both the X here, or Y, however you want to call it. X, Y. It's typically you can find them under $200, maybe on eBay. They're not a fancy table, but for what I'm trying to do, yeah, it's $200. I was gonna make another table similar to my Z control here, with linear bearings and stuff, but really for the $200 and for what I'm trying to do, I kind of just wanted to get to the point where I can get it up and going. And like I said, this has actually been up and running. I did some structural work squaring the machine that you guys haven't seen, but I'm just trying to make the machine more rigid and better. This plate here, don't really worry about it because I see this plate coming away. This plate's going to go away. It's held up with a 5/8 cap, but eventually this whole plate will probably go away. That was another project I had from years ago, but just for mock-up and measurement, that's what I wanted to do. I believe I showed you guys, and again, don't give me crap for my welding, I'm out of gas. I mean, I'm kind of almost embarrassed by this, I'm about ready to fill it up with Bondo and sand it down, but structurally it's not moving. But let's get back to my video here. Limit switches. We have a machine that's going to work in 3 axes. We're going to have an X, a Y, and a Z. I showed you the Z. I'm going to go ahead and show you my limit switch solution to the Z. I got all the way down limit, and I have all the way up limit, so that when this platform that's going to carry my motor, eventually when I figure out what I'm going to do, goes all the way up, it hits the limit up here, and I'll show you. You can hear it click. And then when the platform comes down, it hits the lower limit right there. So I have my Z established, and this could be anywhere from however long you guys want to make it. On the Grizzly mill, but the Grizzly table, I have aspirations to do a flood cooling enclosure, so I kind of wanted a drip edge. So I foresee most of my coolant coming from the front of the enclosure, which would be where I started the video, to the back. This technically is the back of the machine. So here's going to be my Y limits. and a limit there for that distance, and I got a limit here for this distance. And what I did is I just machined a couple angles so that when the table moves back and forth, it will hit those limits. Now, to the x-axis, what I did is, I think in a previous video I talked about bearing supports and what I'm running for lead screws. If you guys want to know information for what I'm running in lead screws, it's a 1/2 inch 13 all thread lead screw right from a hardware store. And basically what happens is the table comes back and will hit this limit. Now, all these aluminum cylinders you see have a thrust bearing in them. So this is a fully thrust bearing supported table, in all honesty. You can kind of see one here. You know, there, once the table, this part here will come back and it'll hit that and stop it. I haven't done any of the wiring for the X, Y, and Z's yet. And that'll probably be another video about how to wire X, Y's, and Z's. If you have any questions about doing thrust bearings, like what's in here, there's a thrust bearing here. There's 4 thrusts all around it. The only thrust bearings I don't have are actually in my Z-axes. I have plans to maybe convert those over to thrusts. But this actually is a working prototype, so take it with a grain of salt. But it will run, and it has cut metal everywhere from basic steel to aluminum. But I wanted to go over the limit switches. So we've already established our limits for all of our axes on how we're going to run this thing. And I guess that's my limit switch addendum and what I did for my table. Now, it'd be far, in all honesty, for guys that are looking at building something like this, this is the cheap route. What I did, I got about, I don't know, the table is probably $200. Steel is what I had laying around. I would honestly try to find a machine like that, which is just your basic Grizzly or your other machine. Not Grizzly, yours. Central Machinery or whatever, your basic, I don't know, I suppose they call it a tabletop milling machine. Unfortunately, this makes a lot of the parts for this, so you'd almost need 2 machines. You know, I'm not bad with the lathe, but to be honest with you guys, this is what I did. I'm not saying it's the right way to do it. This is how I'm doing it. Again, I'd like to try to run inductive proxes versus these crappy things, but it's really not in my budget right now. I have provisions that if you wanted to, you gotta kind of think ahead a little bit. Make your stuff bigger than what you're gonna need, because you can always make it smaller, right? I have visions eventually in the future of putting an inductive, and then instead of having an aluminum puck here, we'll do a steel puck. So that you would have an inductive prox, replace this switch here, and instead of an aluminum ram, or ramp I should say, you would have a steel one so that when the table moves this direction, it triggers it. And then you could actually implement inductive, a switch that'll just bolt right onto the side of this so that when the X comes back, rather than hitting a limit, you hit an inductive. I mean, really, that's the way to go. But you know, these switches are a couple, $3 a piece. I have way covers kind of figured out and started what I want to do for way covers, just to try to keep the liquid out of them. But this is where I'm at. This is how I'm doing it. So I thought this would be a good part to show you guys, part 4 of the homebrew CNC.